In 1973, a man was dragged off a plane for refusing to give up his seat. That moment sparked one of the most controversial practices in modern business. A strategy so profitable that airlines still use it today, despite the outrage. It's called overbooking. And it's not a mistake, it's math. Because every empty seat on a flight is lost money forever. Once the plane takes off, you can't sell it again. So airlines learned a game that balances profit, risk, and human behavior better than almost any industry. Here's how it works. Airlines know that not every passenger shows up. Some miss connections, cancel last minute, or switch flights. Historically, about 5 to 15% don't appear. So instead of selling 180 seats on a 180-seat plane, they sell 190. If 10 people don't show up, perfect. Full plane, maximum profit. But if everyone shows up, someone gets bumped. To passengers, that looks like chaos. To economists, it's optimization. Because airlines are playing a game of probabilities versus penalties. Let's imagine a simplified version. If a seat sells for $300 and the flight has 180 seats, full capacity makes $54,000. If 10 people no-show, that's $3,000 in lost revenue. So they sell 190 tickets, expecting 10 no-shows. But if everyone arrives, the airline must compensate the bumped passengers, say $800 each. If just one or two are bumped, the airline still makes more than it loses. If 20 show up extra, it's a disaster. So the goal is to find the sweet spot, the level of overbooking that maximizes profit on average, not per flight. It's a calculated gamble. Each airline has teams of statisticians running simulations on millions of flights, adjusting for season, route, day, and even weather patterns. But here's where game theory sneaks in. Because this isn't just a game against uncertainty, it's a game against you. The airline predicts your behavior. How likely are you to cancel, to show up early, to take compensation and wait for the next flight? You, the passenger, become a player in their optimization model. When they offer vouchers for volunteers, it's not generosity. It's mechanism design. They're turning an angry standoff into a silent auction. Who will give up their seat for $400? No one. $600, $800. At some price point, someone accepts. The system reaches equilibrium. The airline avoids forced removal, the passenger feels compensated, and profit remains intact. It's pure incentive alignment. But what's fascinating is how airlines use information asymmetry to stay ahead. You don't know the exact chance of being bumped. They do. You don't know their true cost curve. They do. So they can nudge the system, using limited data disclosures, strategic offers, and small uncertainties to keep passengers predictable while profits stay high. And that's why, statistically, overbooking increases revenue by up to 3% per year industry-wide. That may sound small, but in a trillion-dollar industry, that's billions. Still, there's a paradox. The same model that maximizes profit also maximizes public outrage. Every viral video of a passenger being removed costs reputation, trust, and sometimes market value. So the game shifts again. Airlines start using reputation management as another player in the system. They raise compensation caps. They use machine learning to predict which flights can safely oversell. They reward loyalty members to increase cooperation and reduce rebellion. Each move is strategic, not moral. Because from a game theory lens, the passenger-airline relationship isn't about fairness. It's about incentives under scarcity. You want your seat guaranteed. They want every seat monetized. Both can't fully win. So the stable outcome, the Nash equilibrium, is overbooking with controlled compensation. A balance between efficiency and outrage. Now, here's the deeper layer. Overbooking exists because people are unreliable players. If everyone showed up on time, every time, the system would collapse. Airlines depend on our unpredictability, and we depend on their willingness to take the risk. That interdependence, the dance between individual behavior and collective optimization, is what keeps the entire network profitable. It's the same logic behind banks overlending, gyms overselling memberships, and concert venues overselling tickets. They all count on a fraction of us not showing up. In economic terms, it's called expected value exploitation. In human terms, it's called hope. Hope that someone else cancels so we can still get a seat. Hope that the flight isn't full, so boarding goes faster. Hope that the system works, even when it bends the rules. So next time you're told your seat's been given away, remember, you're not a victim of bad luck. You're a statistic in a trillion-dollar strategy, a tiny move in a global game where efficiency beats fairness almost every time. The real question isn't why do airlines overbook? It's would you run it any differently if your bonus depended on a 1% profit increase? Because once you understand the math, the outrage starts to fade. And you realize overbooking isn't a flaw in capitalism. It's one of its purest forms. If you want more videos about how strategy and math explain everyday chaos, subscribe.